December 21 79. Today we discuss lab number 2 of DSP. So we start from task 1. In task 1 we actually plot discrete function. So first of all we define three constant as n0, n1, n2 which are valued with -1, -3 and 3. -3 and 3 basically is the range of the plot. After that, n vector range from n1 to n2, and we have x which have condition. So for discrete plotting we use stem command, and after using this command we get output as shown in the figure. Now moving towards task 2. Task 2 is same like previous task with some difference. First of all, we define three constants n0, n1 and n2 which are valued with -1, -5 and 5. These are the range of the plot. Similarly, we define a vector from n1 to n2, and in x we give the condition, and for plot we use stem command and we get output as shown in the figure. Now moving towards task 3. In task 3 we have two constants n1 and n2 valued as -3 and 3 which shows the range of the plot. We use n for range and we define x is equal to 3 multiply 0.5 power n, and we use stem command for plotting. Similarly, in the second part, n1, n2 from -10 to 10, and then n is equal to n1 to n2, then using stem command, and both result and output shown in the figure. Now moving towards task 4. In task 4 we actually plot unit impulse. So for that we define a function x is equal to unit impulse not 1 and 2. We define a vector from n1 to n2 and define x which is equal to n is equal to n naught, and then end our function. And for calling our function we call our function x is equal to unit impulse, and then we give some value like 0, -5 and 5, and we use same command for plot. After that we get an output only in one plot. Now moving towards task 5. In task 5 we actually plot unit step. For that, first of all we define a function, and then using if loop n is equal to 0, and then end up our function, and then define our function x with given condition and giving the value of range from -5 to 5, and we get the output as shown in the figure, in this figure. Moving towards task 6. In this task we add unit step and unit impulse function. For that, first we define n which is a range of the function and which is -3 to 3. x1 is unit step and x2 is unit impulse. Then add both x1 and x2 and then we use display command to display the result as shown in the output. Now moving towards task 7. In task 7, actually we flip our function. So first we define range, which is from -3 to 3, then define array, and then flip this array subplot, and then we use stem command to display discrete function. Then give subtitle, which is original signal, and axis. Use subplot, then stem, and then title, flipped signal, and then we get the output as shown in the output. Now moving towards task 8. In task 8 we define a signal array 1, 2, 3, 4, 5, 6, 7. Then we scaled our signal. So we give scaled factor which is 2, then plot the signal, then hold on and then plot the scaled signal. Then we get the output as shown in the output. Moving towards task 7. In this task we shift our signal. For that first we define time, then define our function, then shift our function, then use plot command, then hold on, then plot the shifted signal, and then we get the output as shown in the output. That was the original signal and that was the shifted signal. Now moving towards task 10. In this task, we define zero hold order function. For that, first we find line space and then define frequency and define our function, which is sine function. Then define time, then use frequency formula and time formula, zero scale, then start for loop, then end up our for loop, then use subplot and give title, subtitle, and subplot again, then use stem and give some title. After that we get the output in continuous signal and discrete time signal as shown in the output. Now moving towards task 11 and the last task of the lab. In this task we have an input signal that is 1, 2, 3, 4, 5, and we define time which is 0.1. Then we define n and output signal, then starting for loop, and we define output signal, then use subplot, stem function and title. After simulation we get input signal as well as output signal. So in the output, as you see, that was the input signal and we get the output signal. That's all about the lab 2 of DSP. Thanks for watching.